Okay, we are on page 278. And we're going to use properties to identify whether or not expressions are equivalent. And I'll show you how to use properties for that, and I'll also show you how to test it. So the first thing we're going to go back and review is the distributive property. And the reason why I just want to look at that one real quick is because the book here is showing us that both A and B are examples of the distributive property. So let's go back and read that. I'm going to do that a few times. The distributive property, there's only one. Most of these have two, the associative property of addition and the associative property of multiplication. But the distributive property, there's only one. And here's the distributive property. It says multiplying a number by a sum or difference is the same as multiplying each number in the sum or difference and then adding or subtracting. So basically what that's saying is that if you have a problem that looks like this, one way to do it is instead of doing 2 plus 4 and getting 6 and then adding 6, instead of doing that, what you can actually do is you can actually take this 6 right here and multiply it by 2 and multiply it by 4 and then add at the end. And it's shown right here that we're going to do 6 times 2, and it's shown right here that we're going to do 6 times 4 and then add them up. So we do 6 times 2, that's 12, and then 6 times 4 is 24. We add those up and we get 36. So let's go look at that in action. We're now on page 278, and we're on A. And the first thing it's asking us is, are the expressions equivalent? So they give us two. If you're like, what does all this mean? They're basically giving us this question. It's 3 parentheses x minus 2. They're asking, is that equivalent to, and they're giving us the second one, 3x minus 6. They're putting a semicolon in between, but what they're doing is they're listing two expressions, and they're asking you, are they equivalent? And so what we're going to do here is we're going to use the distributive property to determine if they're equivalent. And what is the distributive property? The distributive property is you take this 3 right here and you multiply it by everything inside the parentheses. What's 3 times x? It's just simply 3x. What's 3 times 2? 3 times 2 is 6, and then this sign comes down. So when I use the distributive property on this expression, I get 3x minus 6. Is 3x minus 6 equal to 3x minus 6? The answer is yes. They're equivalent. They don't look like it here. If I highlight this one and say, is that equivalent to that? They don't look equivalent. But some kids noticed, hey, isn't 3 times 2 equal to 6? So you actually have you might have an instinct that it is equivalent, and it was. And it says right there. It says right here, 3x minus 2 and 3x minus 6 are equivalent expressions. Now this next one won't be equivalent. Watch. We're on B now. Again, they give us two expressions. They give us 2 plus x, and they give us 1/2 parentheses 4 plus x. And they say, are they equivalent? And we have to decide if they're equivalent. I'm going to go to this side over here. I'm going to use this distributive property. To remember, the distributive property states that you multiply the number outside the parentheses by everything inside the parentheses. What's 1/2 times 4? Well, 1/2 of 4 is 2. And then what's 1/2 of x? Well, 1/2 of x is actually just 1/2 x. 1/2 of x is 1/2 x, like that. And then I bring my sign down, I get 2 plus 1/2 x. Is 2 plus 1/2 x equal to 2 plus x? They're not exactly the same. 2 plus x is not exactly the same as 2 plus 1/2 of x. So the answer is not equivalent. That's all we're doing, is we're using properties to determine whether or not they are equivalent. Okay, let's move on. We're going to practice on here. Your turn. We've got number 6 and 7. It says, use the properties of operations to determine if the expressions are equivalent. In other words, is this 6x minus 8, is that equal to 2 parentheses 3x minus 5? Do you have some instincts here about whether they're equal or not? They look like they might be. Check it out. On this side over here, I've got parentheses, so I need to do 2 times everything inside the parentheses. 2 times 3x is 6x. And this is 6x. Oh, that's a good sign. They're going to be equivalent. 2 times 5. What's 2 times 5? It's 10. And then I bring my minus sign down. This side over here is 6x minus 10. This side over here is 6x minus 8. Are they equivalent? The answer is no. Should probably rewrite it like this. we need to put this right here. 3x minus 5 is equal to 6x minus 10. And then we need to say not equivalent. And why aren't they equivalent? There's one little thing that makes them not equivalent. They're not equivalent because minus 8 is not the same thing as minus 10. If this were minus 8, it would be equivalent, but it's not. All right, let's move on. Let's try another one. Ooh, I messed up. I need to undo that. All right, so I'm on number 7 now. Number 7 is 2 minus 2 plus 5x. Is that equal to 5x? If you're wondering where I'm getting this, it's because this semicolon right here is separating the two expressions. The first expression is 2 minus 2 plus 5x. Well, what is just 2 minus 2? It's just 0. 0 plus 5x. And is 0 plus 5x the same thing as 5x? It is, because there's a property. It's the identity property of addition. And the identity property of addition, the exact words are, adding 0 to a number does not change its value. So if you're trying to add 0 to 5x, you could actually just take that off altogether. So now I have 5x equals 5x. The answer is equivalent. What work am I going to show here? I'm going to show this work right here. I'm going to do 2 minus 2 plus 5x is equal to 5x. Because 2 minus 2 is 0, and 0 plus 5x is 5. It's just 5x. So I'm going to write equivalent here. That's all I need to do. Let's write equivalent. Okay, we've got one more problem to do. Let's go ahead and I might have enough room to not need a whiteboard. Oh, I didn't want to do that. All right, number 8 reads, Jamal bought 2 packs of stickers and 8 individual stickers. Use X to represent the number of stickers in a pack of stickers and write an expression to represent the number of stickers Jamal bought. Is the expression equivalent to blank? It says 2 parentheses 4 plus X. Check your answer with algebra tile models. I'm not sure we're going to do that, but we'll see. So Jamal bought 2 packs of stickers and 8 individual stickers. Well, we're going to go ahead and write here, and it says use X to represent the number of stickers in a pack. Well, he bought 2 packs of stickers, and there's X stickers in each pack. And then he also bought 8 individual stickers, so we're going to also add 8 to it. So let's go through what these numbers are. He bought 2 packs of stickers, and there's X stickers in each pack, and he also bought 8 stickers. So it's 2X plus 8. This is the first part. We just answered this question right here. Use X to represent the number of stickers in a pack of stickers and write an expression to represent the number of stickers Jamal bought. We've done that. Jamal bought 2 packs times X because there's X stickers in each pack, and he also bought 8 stickers. So it's 2X plus 8. And now the question is that equal to this? 2 parentheses 4 plus X. And we're going to find out. It says use algebra tiles to check your answer, but I think you should use the distributive property. The distributive property tells you to multiply the number outside the parentheses by everything inside the parentheses. Well, what is 2 times 4? 2 times 4 is 8. And what is 2 times x? It's 2x. And on this side over here, I had 2x plus 8. And on this side over here, I have 8 plus 2x. And can you change the order? You can. So the first thing was called the distributive property. The second thing is that you can just change the order. That's called the associative property of addition. You can change the order and it won't affect anything. So is the expression equivalent? The answer is yes, or the answer is equivalent. And we don't have to, we're not going to use algebra tiles. I think it'd be much better just to use the distributive property. Okay, I know some of this is confusing. But if you're following along and trying your best, that's all I can expect. Thank you. We are now done with page 278.